We are going to check on where you're at right now. But it's not a quiz.
It's a quiz.
It's not a quiz.
It's a quiz.
Yes, we are turning this in.
So it's a freaking quiz.
It's not a pop quiz. All right.
It is.
Graded?
No.
If you're testing,
But I want to turn
no,
it.
it is.
It's a pop quiz.
Okay, hey.
It's a test.
It's an ungraded pop quiz. All right. Maybe that's the way I'll put it. Ungraded then. All right. So have your piece of paper out. I want you to try your best. Here's what I'd like you to do. I'd like you to write down these 4 problems. I got 4 problems that I'm going to have. I'm not even going to number them. I'd like you to write them down, and then I'd like you to attempt them. I'll give you about 5 minutes to attempt to do these problems to solve it.
Right.
Okay, so here's what we have.
Can we have like 10?
Nope.
5 per problem.
Okay, you'll need a calculator, so you might want to go grab one.
Oh, triangles. Triangles.
Mr. Ward, mine's not my car.
Well, then
I'll
I'll
walk
do that.
around and get it.
Can we work as like a class?
No.
Pop quiz.
Of course, is it no?
Yeah, it's a pop quiz.
It's a pop quiz.
give us a pop quiz.
I can't
Hey, sit down, name, date, get ready.
Abby, sweet.
I'm actually gonna cry.
It's
No, he told us it's a pop quiz. Most of the time, pop quiz.
For
bio?
Sit down again.
What's the date today?
I completely forgot to do this.
September 12th, Jordan.
Thank you, sure.
Drew, will you
But you were the
please
second one to say.
What? 2019 though.
Bounce so I can see the board.
Yeah, I knew
We
that.
should have a pop quiz on the board.
Okay.
I'm doing it.
Oh, I broke my finger.
All right. I would like you, if you have a calculator, to have it out, piece of paper, name, date on it. I would like you to attempt to use 4 problems in the next 5 minutes. This is not a quiz, it's not graded, so get that out of your mind. I want to see where we're sitting, what you remember from last year. I want you to try to get through these. On these first 2, you're solving for x. I want to know the digit, the decimal for x.
That's 5.
That is a 15, that's a 32, that's an x. Over there, that's a 3 sine 4x plus 1. That's a 1/2 cosine x over 2 minus 4.
I don't have that
There's
one
no
paper
5s
with
up
me.
there.
Hey, Mr. Ward.
Other than the
That
15.
is a,
That's a 15.
after the 1, that is a 5.
That is a 15, yes.
That's how you write 15.
Okay.
1, 5.
We haven't done this yet this year, have we?
I don't have
Not
my paper
this
from
year.
last
We
year.
did it last year. I want to see what you remember.
Well, it was this year. 2019.
Yeah, actually, you're right. It would be
This
2019.
school.
This.
Academic year, no. It wasn't
What she
within this
said.
calendar year, yes.
Maybe
Okay, so the first 2, you're finding x. It'll be a decimal. You can give me that in terms of a decimal. The next 2, I would like you to draw these 2 problems as a wave graph. So you're not putting these in triangles, you're drawing the wave graph.
Wait, so like that's number 2, and then that's 3, and that's 4.
1, 2, 3, 4. If you want numbers, I'll put numbers in there.
Okay.
You're just a cruel person.
I know.
I actually don't have this, Mr. Ward.
Yeah, I feel confident in my abilities.
Good.
No.
I'm nervous.
Okay, we are going to turn this in today though, so don't put any random stuff on the paper, just put these 4.
My mom would see.
Okay, now, as you guys are working on this, late work, anything like that, we have a 0 date coming up here pretty soon for, I think it was page 17 stuff.
When is that?
So, 0 date's Monday, so you
Oh,
want to get
Monday? Oh, we're good then.
So, okay.
I'm 3/4 away from Mr. Ward.
The page 26, I think we had the last one. That's due next Friday, and then this assignment. Obviously, we have an assignment due today. The 0 date for that is next Friday. Because next Friday is the end of the midterm. So.
Well, you know, Mr. Ward, I thought the 0 date was tomorrow.
Hey, can you turn on a fan or something? It's really
Open up the windows.
Sorry, I'll put my shirt back on.
So.
We'll cooler.
That's really funny.
Pop quiz, no talking.
See his guts on the other page.
What happened?
That is an intense fight. That's big.
That's not
That would be burning your bag and everything in it.
I can't.
No, that's like, I've had one picture tonight
Are you
falling on me in my room.
Yeah,
Okay.
That's why I want to see it.
that's disgusting.
Okay.
It's not gonna hurt me.
All right.
That's really cool.
Hey.
You shove it there instead of walking like a regular person.
Here's what we're doing today. We have to go through 2 topics today that I want you to pay attention to. Take notes. Then we're going to do a last thing at the very end of class today. I'll be done early, you'll be able to relax. I know we have homework due today, so you can work on that and get it turned in. I want homework turned in today unless you're gone. You have an excuse for an extra day. Page 33, that is the only thing I don't have entered in the grade book. Everything else is entered. Now, if I handed you back papers that you want to make corrections and fixes on, that's due by next Friday. That's in the midterm. Okay, if you didn't get any papers back, because you didn't give me any in the first place. So, that's how it works. Question? No. Okay, question? No, alright.
It is coming down out there.
Okay.
It is raining cats.
Sam, you want to close that window over there?
No, sure.
It's too hot. We'll get some of that nice,
Well, I was getting there. I just we got all the way back.
Is this supposed to rain like this on the water bottle?
I'm probably not going to.
Mr. Ward, that's awesome. Can I get my water bottle?
No. Alright. Okay, here we go. Here's what I'd like you to write down. These are my notes today. We're gonna do a couple problems where we have to solve for a random variable. Okay, so my first one I'm gonna set up. Let's set up something like this, and I'm gonna put a 20-degree in here. All right. So here's the idea. If you have to find a missing side of a right triangle is only for right now. We have to do the trig function. Okay. So the trig functions, we have this little acronym that we use. Yep, SOHCAHTOA. Now, here's the idea. On this little acronym, it's to help you remember how to set it up and basically what formula you should be using. Now, what these stand for. Obviously, the first capital letters are the trig functions. Sine, cosine, and tangent. The second and third letter in each of those, in each of those groups are the actual labels from the picture. Now, how you label them is you find your angle, and then you label all the walls according to where the angle's sitting. So, obviously the wall that's across from 90, this is your hypotenuse. That should always be across from 90. That one's easy. You should never get the hypotenuse wrong. The next one is you have to figure out where the opposite is. That is across from, or the opposite side from the 20. So this is the opposite side here. Yeah. Now the reason why that's the opposite side is you have to find your angle, and you're going across from that's opposite. The adjacent is the one that's next to your angle. So even if your angles switch spots, the adjacent's next to it, the opposite's across from it. The hypotenuse is the only one that really stays the same spot. So now that I know that, I can figure out which of the three formulas I'm using. Most people just know it. But I can figure out which formula I'm using because one of these sides is not even used. So on this particular problem, I don't even need the adjacent. I don't need it. There's not a variable there. So now that I'm throwing out the adjacent, I can get rid of all the A's in that little acronym, and that tells me which one to use. So I'm using the SO formula. That's the easiest way I can explain it to you. Now, to set this up, how it always works, it's whatever trig function you're doing, so sine, in my case. The angle that's in question, so mine is the 20 degree. You never use the 90. You only use the smaller acute angles. Now, the opposite side, this is O, goes on the top, and then H goes on the bottom. The second letter is always on the top, third letter is always on the bottom. So in my case, it's X over 15, because it's opposite over hypotenuse. That's what those little acronyms stands for, okay? Now, to solve this, you have to figure out where the X is. If the X is on the top, like this particular problem, this is the easiest problem in the world, you just multiply the 15 across. You don't need to do anything special. You just multiply it over. So 15 times the sine of 20. And then you type that in, there's your answer. It's whatever the decimal you get.
5.13.
Now, okay, say it again?
5.13.
Sure, sounds good.
Did that?
5.13. Okay, now here's the thing.
3.
As many decimal places as you can, I'll accept 2 or 3. All right, now, here's the idea. I can't predict that every time you get a sine problem, it'll be solved that way. It's just on this particular problem, the X is on the top. That's what told me to move the 15 over. I always get people where they think they have to do a sine problem the same way every time. It just depends where the variable sits. So for instance, if I had a problem like this, and I had this, let's say this is a 62 degrees, this is 10, and this is X, this is still a sine problem when I get going, but the problem is it's not solved the exact same way because of where the labels sit. and where the x will fall in this particular problem. So, all right,
I don't like it when it's drawn out.
so on this problem like this is the opposite side, this is the hypotenuse. So I'm still using the sine form, I'm not using adjacent. So it's sine of 62, opposite over the hypotenuse. Now, do we notice that the x is on the bottom?
Yes, I know.
Anytime x is on the bottom, the variable's on the bottom. What you do is you do a quick switch where you switch the variable and the other side. This is the easiest way I can teach you how to do it. You're trading spots. You're doing an inverse operation. So you move the x to the other and the sine 62. Now the hard part is, if you don't have a very good calculator, this is almost borderline impossible unless you do one thing at a time. Like figure out what the sine of 62 is, take 10 divided by that decimal. Okay, that's what you're doing. Now some people can just type it in, hit enter, and you're good to go.
That's fine.
It just depends on your type of calculator, what you can do on it. Okay, questions on how to solve that. Notice, it's still a sine problem, but it's solved completely different.
This is 17.
005.
Now, here's my question. Here's the follow-up question. What if I wanted that angle?
Oh, dang.
You can use the inverse thing, but
I can use the inverse button, or what somebody else say?
1 plus 62.
Yeah, you just take the 180 and subtract the other two angles.
oh yeah, you can.
These two angles have to be complementary to each other. They have to be complementary, so this should be a 28.
Yeah.
Because the two smaller angles have to add up to be 90 in a right triangle. That was a major property of geometry that we talked about. It was one of our theorems we had. It was a corollary that the remaining two acute angles of a right triangle have to be complementary. They have to add up to be 90 degrees. But you could do inverse functions. You can. If you set up, the sign of the question mark, the angle I'm trying to find is the opposite wall. We're going to do cosine, I guess. Cosine of this is the adjacent over the hypotenuse, and we already figured out what that hypotenuse number was from earlier. I could do an inverse cosine button. Because to solve for this, you can do the inverse to the other side. The cosine -1 that's what's used to find angles. But again, that's doing too much work compared to what you could do if you just think about it. Questions on the basic trig functions. Now obviously, I'm just focused on the main three. Sine, cosine, tangent. They all be solved the same style, the same types of buttons. Is there any questions or anything you'd like to see just to make sure you know how to do it? Okay. The next thing I want to talk about is if you had to graph and draw those wave functions. That's the other part of this assignment we have coming up. Because they have two separate parts. They want you to use trig functions, and then they want you to graph the wave functions. So, let's do that. All right. So, let's go through the steps here. Once we get through this, I think you'll be fine from what we had earlier. Okay, for the wave graphs, I'm gonna just put up some numbers here, or some variables I mean. Bx plus c. Okay, so I'd like you to write this function down. We're gonna talk about some numbers. This is my formula, my generic formula I use when I draw. Okay. So, what these letters, these variables stand for? They stand for amplitude, period, and the origin line, the shift, the vertical shift. So this number here affects amplitude. Amplitude is the height of the wave from the middle, the origin line. So the wave will be up 1, down 1, or up 3, down 3 from the middle line. The B number is the period or frequency. It's the actual drawing of it. It's how many you would actually draw in that particular picture. If you're drawing 5 times that many, or a fourth of that distance, that type of thing. And then the last number is the vertical shift. This is the origin line. It is a shift, a vertical shift. That's how I think of it. When we go through these, this is what I think about. I think about where do we shift it? Where is the amplitude going from there? and where's the, the period from those 4 hash marks. These are all the numbers that affect my drawing. Now, obviously, one of the things we're going to get probably on either tomorrow or Monday is we need to talk about more of like the horizontal shifting, right and left shifting. That was something I introduced last year at pre-calc, but I only did like 1 problem and I never gave you any homework on it. I just said this is something we're going to eventually get to, and we're doing it this year. Okay, so let's walk through this. So here we go. Let's give you some numbers here. So let's go with like
24.
5. Okay, I'll use that. 5 sine 2x plus 4. I'm going to use the 2 and the 4.
55.
No, I'll do that next. All right. So here's the idea. The sine graph by default looks like this. This is the default sine graph. It looks like an S for sine. It normally starts at 0. It has 4 major marks that it hits as it goes along. It has a peak and a valley. We are moving this picture and manipulating it from where its normal spot. Typically it hits 1 and -1. It hits 2 pi, and then we cut that number in half, cut that in half, multiply that one by 3, because it's the 3rd mark down the road. That's like the trick that we did a long time ago. What we have to do is we have to manipulate all of these numbers with these 3 digits. So the first thing I do is let's shift it up 4 spots, right? Does everyone understand like where this thing's going by default? That's the original picture. That is not my answer. That's what I'm going to manipulate to a new spot. So here we go. So on my particular drawing, we're shifting this up 4 spots. Okay, I'm shifting up 4. That is my new origin line, positive 4. Again, this shifts it up 4. That's where that came from. Question?
Do we have to put like the dotted line?
No, I just put it there so you can see it. Yeah, you do not. It's not required. I just like to have it there because I like to know where like the middle is. Okay, now from there, the wave, the amplitude is going up 5 and down 5 from there. So that means what will be my peak? 9. Okay, 5, 6, 7, 8, and 9. I'm going to hit a peak of 9 and a valley of -1. That's 5 below it. Does that make sense? How I shifted up 5 and down 5. Now the 4 hash marks going across. I don't care where you put them. This is why I do the dashed line. I like to draw my 4 hash marks on that line itself. Now, do you need to do that? No. I've seen some people draw it where they just draw it like this. And they just tell me this is 4. And 5, 6, 7, 8, 9. And they go down to -1 like that. I'm totally fine with you doing that drawing, but you just have to label all your numbers if you're doing it that way. I like to show it like this. I like to know where the original 0 was. Okay, now, my normal hash mark was out to 2 pi. That's my normal hash mark. But for me, this affects my period, my frequency. So normally what we do is we take the 2 pi that we normally would hit, right? And you always divide by the number that's in front of x. Even if it's a weird decimal, or a pi, or a fraction, you divide by whatever that number is. Even if it's a fraction, you divide by the fraction. In my case, I'm dividing by 2, because that's the number in front of x. So what happens to that number?
It cancels.
Pi.
Cancels, so it's just pi. The 2's canceled, and that's my 4th hash mark down the road. So then I cut that in half, cut that in half again, multiply that one by 3. Half, multiply by 3. That's how it always works. And now I can draw my sine graph. Starts at 0, goes to its top point, comes back to 0, goes to its lowest point, comes back to 0. It looks like the same picture, but it's stretched. What's actually happening here, it's 5 times taller in amplitude, like in terms of like how loud it is. If we're talking about like a sound wave, 5 times louder.
The thunder.
It's in a different pitch completely, and the frequency's been pushed together. So the frequency would be the actual note itself. So like a C versus a G, that type of thing. Okay. So they crammed it together. Now, what this 2 tells me, I can literally draw 2 of those in this picture. It would literally do 2. It would go. That picture would be up 4. It'd be up here. That would be 1 full graph, and then it would do another one before it got back to 2 pi. It's literally doing 2 of the frequencies, 2 period lengths in one normal picture. That's what it's doing. You can actually see it. It ended at pi. That ends here. It's doing 1 full picture, it's doing another full picture. Does that make sense?
Yes.
Okay, that's sine. Let's do cosine now. And I'm going to introduce some fractions in here.
Is this the last one?
This is the last one today.
Aw.
Dang it.
2 more.
No.
3 more. Let's do tangent.
How
Nope.
about zero?
Nope. Okay, here we go. Last one today.
Just call it a day because I'm scared because of storming outside.
Maybe we should-
Maybe
I don't
Sam.
want my mom.
Okay, all right, here we go. Let's go with 1/4 cosine 1/3 x, and we're going to go -1. So we're throwing in everything here. Okay, so a cosine graph, the normal graph for cosine does this. It normally hits 2 pi. We cut it in half, multiply it by 3. So here's my normal picture. And cosine normally starts at the tallest point, comes to 0, goes to the lowest point, comes to 0, goes to the highest point.
Plus the weird one.
It looks like a U shape. If you turn your head, it looks like a C. It's a C shape for cosine. Now,
C is blue.
okay. So what we're I can't handle it. All right. So what we're gonna do now? We're gonna mess with this graph. So we're gonna shift it down. So we're going down 1. The amplitude is 1/4 is tall, so it's like 1/4. It's really like crammed together. And then the period or the frequency of this thing is literally 1/3. It's stretching this thing out horizontally. It'll do 1/3 of a picture by the time it normally does this full. It does 1/3, so it's really stretched out. It's doing 1/3 of a full picture. So here's what it's going to look like. Now it may not look very different compared to what I have on the board, but it is when you actually compare them like on the same graph. It would be majorly different. So we're at -1, that's my shift. From there, I'm going to go up 1/4 and down 1/4. So I'm going to hit, I'm going to hit 3/4 here. That's -3/4. And then this is -1 and 1/4. That's going down 1/4 and up 1/4. The 4 hash marks going across. The 4 hash marks going across. Normally I hit 2 pi. But in my case, I'm taking 2 pi and I'm dividing by the number in front of x. So in my case, I'm dividing by a 1/3.
So you just multiply by.
Yeah, so when you divide by a fraction, you just multiply by the reciprocal. So this ends up being 2 pi times 3, that's the reciprocal. So it's 6 pi. So my hash mark down here is 6 pi, cut it in half. 3. So it's cut in half, we cut it in half again,
You're filthy.
and we multiply that by 3. So there's my numbers I have. Cut in half, multiply by 3. And now I'm going to draw. So cosine starts at its highest point, goes to 0, goes to its lowest point, comes back to 0, goes to its highest point, and here's my graph. Now it doesn't look very crazy compared to this one, but it would be shifted down and it would be really skinny and it would be really stretched out compared to this one because it's literally doing 1/3 of the picture by the time it gets finished. That's what it's doing. Okay, questions? Now, here's what I'd like you to do. Okay, you can keep your notes out, keep your pencils out. I'm going to put those 4 problems back on your desk. And I want you to try to attempt them again now. Okay? You can put them down below, you can put them right on top. I want you to try those 4 and you have less than 5 minutes to do it. Okay?
What if I already did it right?
Then you're fine, you can double check to see if you did it.
I think there's a little bit of room for improvement.
Thank you so much.
I can still like
You put your
do
name.
like half the problem and still
Yeah, I have to say.
Now I don't, what's the problem, man?
Process of elimination.
Samuel.
I'm gonna do it in this way. edit.
What is your problem? What's your
I
problem?
mean, in the grand scheme of things.
Okay, I'm going to put the problems back up on the board because you probably need to see them.
That would be a.
No.
If you're already done, finished, complete, that's fine, you can turn it in.
Okay, so
Use your notes to help you out.
this one.
question?
Got to set the final.
That's right.
Nope.
The first two pictures, they're Sine and Graph.
Yeah, there. That's what I got.
Hey,
That's not at all what I did. I know. I just.
Hey, don't help each other. Sam, go sit.
I'm sure it is our homework.
Why is that not so?
Oh, this one's different. I also
I'm
got
not.
14 rows.
When was the last time I asked for help, Jacob?
The answer is 5%, I guess.
Yeah, that was
Why
right.
would he? Oh, you wrote the answer? Yeah. How'd you get stuck?
Whoa.
Yeah, there is.
Well, I shouldn't just update
I'm gonna use Slater.
No.
Am I gonna
Or use Slater.
No.
Using Slater right now.
that for no reason. I got that, and then I just did that and got the same picture.
Well, we got that one shared
You did a law of sine. It gives you the same
Should I
response.
borrow this?
Wow.
It works on any type of triangle, not just a right.
Will you fix that last one up?
Something we'll just talk about. That's something a lot of people. That's something that a lot of people did, like didn't
I did that right the
register
first
again.
time. Thought
It
it
was
was
the same thing. They literally do the same thing.
So,
That's like the next section we're doing.
What was the number 4?
They're up there.
It's up there.
I'm blind.
You can go.
whoa.
I have 4 eyes.
There's no number in front of that.
Okay, if you get done, finished, complete with your problems, you can turn it in. If you're gonna make any major fixes to those previous assignments we did, you can turn those in. Those go up through next Friday. If you have any blank LIs in the grade book, I think page 17 is due by Monday, and the page 26 is due by next Friday. That's the zero.
Is there a give up option?
No.
Why I hit that joystick right?
Okay, so.
Just throw in the towel, bro.
Yeah. Yeah.
So it'd be like 2 pounds.
There we go. This is